All right, this is video number 7. We are looking at page 9 in the notes of Physics Unit 1. So in the previous video, we arrived at a definition and a formula for acceleration. At the top of the page, I am going to write our formulas for acceleration. It's on the previous page of your notes. Acceleration equals the change in velocity over time. Or a second formula, you could say this is final velocity minus initial velocity divided by the time. These are the formulas we're going to be using today in this video. So as you can see from the definition and the formula, you don't have bragging rights by simply saying, my car can go from 0 to 60. To calculate acceleration, we must ask, yeah, but how long did it take? So as we work some examples on acceleration, we'll discuss some of the strange units that result, and we'll see them as they come up. Calculate the acceleration of a car. So we're looking for A. So example A, goes from 40 miles per hour to 50 miles per hour in 5 seconds. So first, let's identify the things that we even know here. Goes from 40 miles per hour. That's an initial velocity. To 50 miles per hour, final velocity. And 5 seconds is time. So remember, in physics, we are always starting with formulas. We are always showing our work. Acceleration equals the change in velocity over time. Or it could be said, final velocity minus initial velocity over time. And here we can plug in our numbers. Our final velocity, 50 miles per hour. Our initial velocity, 40 miles per hour. And our time is 5 seconds. So what we find is that our acceleration is, it's going to be 10 over 5. It is 2 miles per hour per second. Or another way you could say the units, it would be, or miles over hours times seconds. So what this miles per hour per second is telling us is that every 1 second, the speed of this car is increasing by 2 miles per hour. So after 1 second has increased by 2 miles per hour. 1 second later, it has increased by another 2 miles per hour, and so on over the duration of this 5 seconds. B, a car that goes from 40 miles per hour to rest in 8 seconds. Goes from 40 miles per hour. That's an initial velocity. To rest, that's going to be a final velocity, and specifically, that's a final velocity of 0 miles per hour. So I'm going to put a formula here. Acceleration equals final velocity minus initial velocity over time. The formula delta V over T is not necessary if we're showing the second version of the formula. My final velocity is 0. My initial velocity is 40 miles per hour. And the time is 8.0 seconds. So we have negative 40 divided by 8. That is negative 5 miles per hour per second. Negative 5 miles per hour per second. And a negative acceleration means deceleration. if you want a better mental picture of what's going on in example B, this is a car that's driving down the road and it's approaching a stop sign and it slows down, comes to rest at the stop sign over the course of 8 seconds. So negative acceleration means deceleration. We're slowing down in this situation. C, a car goes from 40 feet per second to 60 feet per second over the course of 4 seconds. So let's identify what we have. There's initial velocity, 2, that's final velocity, and here's our time. Acceleration formula. Final velocity is 60 feet per second. Initial velocity, so we're minus 40 feet per second over the time, which is 4 seconds. 60 minus 40, we end up with 20 feet per second over 4 seconds. So our acceleration is 5 feet per second, which you could write as feet per second. Or the third, and probably the most commonly used for this, would be feet per second squared. So these would probably be the best unit to use. So let's rewrite this. Acceleration equals 5 feet per second squared. Example D, the car goes from 40 meters per second to 30 meters per second in 5 seconds. So from 90, that's VF, to 30, excuse me, let me erase that. From 90 is initial velocity and to 30 is final velocity. 5 seconds is our time. Acceleration, final velocity minus initial velocity over the time. Final velocity is 30 meters per second minus the initial velocity, 90 meters per second. Time is 5 seconds. So what we have here, 30 minus 90 is going to be negative 60 meters per second, and over 5 seconds, our acceleration in this example is negative 12 meters per second squared. So again, we have a negative acceleration, that means decelerating. Units are meters per second squared. Let's look at the next one. Number 2, a truck accelerates at a rate of 8 miles per hour per second for 3 seconds from rest. Find its final velocity. This one's different. We are taking the acceleration formula and we are manipulating it to find the final velocity. Accelerates at 8 miles per hour per second. So we have an acceleration. For 3 seconds, there's our time. From rest, that's initial velocity, and that's 0. Find its final velocity. So we want to know what is the final velocity. What is VF? So here's what we're going to do. We are going to start with our acceleration formula. And we are going to solve for final velocity. So probably the easiest way to do this is to put the acceleration over 1, which didn't change the number, it just puts a number under. and we're going to cross multiply. So you would end up with VF minus VI, going this way, equals, on this side we have AT. And we want final velocity by itself, so we are going to add initial velocity to both sides, and we end up with final velocity equals acceleration times the time plus VI, or the formula that you will see on your actual formula sheet looks like this. Final velocity equals initial velocity plus the acceleration times the time. I'm gonna box this off. Something good to remember that you can solve for things. I would probably discourage memorizing every formula that we have. It's good to have this one memorized and just know how to get to here. So we have an initial velocity of 0 from rest plus the acceleration, which is 8 miles per hour per second, and the time, which is 3 seconds. Let me change the way I wrote the units here to make it a little easier for us to visualize what's going on. We have 8 miles per hour per second. So then we can look at it and we can see a little better that seconds are going to cancel. Our final velocity is 8 times 3, 24 miles per hour. Number 3, a boat traveling at a speed of 8 meters per second, then accelerated at a rate of 2 meters per second squared for 7 seconds. Find its final velocity. So this boat is traveling at a speed of 8 meters per second. That's an initial velocity. Then it accelerates at a rate of 2 meters per second squared. That's our A, acceleration. For 7 seconds, that's the time. Find its final velocity. We're going to use the formula that we found in example 2. Final velocity equals initial velocity plus the acceleration times the time. So we solved for it here. I'm not going to do that again. Just know that this is where it's coming from. So let's plug in the numbers. So we have an initial velocity of 8 meters per second plus our acceleration, 2 meters per second squared, and our time of 7 seconds. With the units, here's what's going to happen. Seconds here is going to cancel with one of the per second here. So we're going to get rid of the squared. And we're going to end up with meters per second plus meters per second. Final velocity equals 8 meters per second plus 14 meters per second for a final velocity of 22 meters per second. Number 4, how long will it take an object to accelerate from 12 meters per second to 30 meters per second if a equals 3 meters per second squared? So this question is asking how long. We're looking for time. To accelerate from 12 meters per second, initial velocity, to 30 meters per second, final velocity, if a equals 3 meters per second. So let's start with our acceleration formula again. So when we are going to solve this equation for time, what we're going to do is multiply both sides by time. That's going to get rid of this t, and it's going to put time over here with the acceleration. And then we divide both sides by the acceleration. That's going to get rid of this. It's going to put it down here. Short version of what we just did, we are switching the a and the t. So we end up with time equals final velocity minus initial velocity over the acceleration. We have all three of these quantities. Now all we have to do is plug it in. Final velocity is 30 meters per second. Initial velocity is 12 meters per second. Acceleration is 3 meters per second squared. We're going to do the next step before we try to touch the units. So we're going to say time equals, so 30 minus 12 is 18 meters per second, and 3 meters per second squared on bottom. So here's what's going to happen. So we have meters on top and meters on bottom. Those cancel. We have a seconds on top. We have seconds squared on bottom. So one of the seconds will cancel, and it will leave the other seconds here. So what we end up with is a time of 18 divided by 3, and it's per second, which takes to the top, which is seconds. And that's what we were expecting. Time should be in seconds because everything in the question was in terms of seconds. Number 5, a train accelerated at a rate of 0.3 feet per second squared for 40 seconds to reach a top speed of 20 feet per second. What was the original speed? Labeling what we have. Acceleration, 0.3 feet per second squared. For 40 seconds, there's our time, to reach a speed of 20 feet per second squared. Final velocity. The question is asking what was its original speed. That is VI, initial velocity. So we're going to start with our acceleration formula, final velocity minus initial velocity over the time. And we're going to solve for initial velocity. So what I'm going to do here is multiply both sides by time. That's going to get rid of it on the bottom, and time will be over here with the acceleration. Acceleration equals final velocity minus initial velocity. So then I want initial velocity all by itself. I'm going to add it to both sides. So I'm going to have VI plus AT equals final velocity, and then subtracting both sides by AT. For a final formula of initial velocity equals final velocity minus acceleration times the time. Here's the formula that I'm going to be using. Put it in the box. Okay, so I'm going to move back up here. Initial velocity equals, we have a final velocity of 20 feet per second minus the acceleration is 0.3 feet per second squared, and its time is 40 seconds. So over here, seconds will cancel with seconds squared. We're going to be left with feet per second. So we have initial velocity equals, say, 20 feet per second minus 12 feet per second. Finish it up, and initial velocity of this train is 8 feet per second. One last note on all of these. So there are 4 different terms in this equation, and we're given 3 of them. At the end of the problem, you have the 4th term as your answer. And so if you want to check your answer, all you need to do is go back and plug that number in, just like in your math class. And as long as everything works out, then you'll know that your answer is correct.